about to move my stick figure trading application, Mercati Maestro, the trading master. I'm going to move it to the next level. So I am currently in the design phase for a fixed translator, and I need to connect it to the database. A couple things going on. So first thing is, we're moving to the cloud. We're going to the cloud, baby. Woo! AWS. I already got my AWS set up. I don't have a database set up yet, but I'm about to. So I want to be able to have event triggers, which is why I'm leaving SQLite behind. I don't believe SQLite supports this. I want this to be as close to the real thing as possible. So we want low latency. We want real time as possible. Polling, is it polling or pooling? Polling is the alternative where it's like a loop type of thing. Not an actual loop, because, well, I don't know if it's a loop or not, but I know loops can be very inefficient. But the basic idea is you have this cycle of every 5 seconds or every second check, is there a new order? No. Is there a new order? No. Is there a new order? Oh, there's a new order. Okay, now I'm going to do something. Like that. That's no good. I want, as soon as you hit that send button, you enter your order details. Slow down. You enter your order details. And then you hit the send button, and then it's like, boom, insert to database, boom, trigger, boom, translator picks it up, translates it into fix. So the way this would work is, again, set up the database in AWS. I'm going to use RDS. RDS supports these triggers. So I would have a database set up in AWS. I have my trading application running locally, connected to the cloud, to the database. And then whenever an insert occurs, I have a trigger set up, and that trigger will basically recognize that there's a new order. And I don't know if this is necessarily would this be a webhook or API? Because I know AWS has this Lambda API deal where it can listen for events and be able to communicate with another application. But I may not need to use the API, so if I host everything on the cloud, which is what I might be doing, so I might be moving or changing the design to be the client runs locally on my machine, and then everything else in the cloud. I have the database in the cloud, I have the translator in the cloud, I have the smart order router, the UDP market data, pretty much host the entire thing in the cloud environment. And the only thing local is the client. So that is what we're looking to do. So a couple of things. I would have to introduce the concept, the feature, the function of a actual new order, because right now it's like a cartoon version of a trading platform. Good to see you, little E and Samantha and Woke I Divided. You remember today was the day you started YouTube channel in 24. Is that true? No way, man. He's a ball ahead. Anyway, so, and click on the like button. Those of you guys that just joined the live stream, click on the like button so other people can join in. So the first thing we want to introduce is the concept of actually having a new order, because right now what we're doing is, remember, I oversimplified things into sort of a cartoon thing. So all I'm doing is I merged instruments into order types. So all you're doing is red versus green. Red is a sell, green is a buy. Green is also the instrument, red is also the instrument. So green is an instrument and a side all merged in one. I eliminated the concept of actual market data. It's just a randomizing thing I did in Python where it's random prices. So I basically, the price is deviated within a certain range type of thing. I'm going to start getting into real market data in the future, but we're not ready for that right now. But what we are ready for is to at least have an actual order. So I'm gonna start with a just a basic new order single, and I'm just gonna make it this my favorite order. You guys been subscribed for a while. You know what my favorite order is. Buy 100 shares of IBM. So that's what's gonna be. So I'm gonna probably create a basically a class, I guess order class. So basically, when you create a new order, you're creating a new order object, right? And once you hit the send, it's going to take all those details that you specified, the quantity, the symbol, whatever. It's always going to be market in this case. And the quantity will be fixed for now. We can add other functionality later on. It's going to do an insert. So first of all, it's the front end is going to have to connect to the database, which is going to be in the cloud. So when you start the application, it connects with the database in the cloud. You start, your order creation, which is that order object, which has all the details. And when you're done, that triggers a write to database function. So you're going to do that insert, send it straight up to the cloud. Then within the cloud, I have this event trigger set up with RDS that will see this event, recognize as a new order, and then I'm in the design phase. So I got to figure out how I'm gonna work this out. But I could have a queue table where pending orders go. So a new order comes in. It could be maybe originally written to the queue table. I don't know, but there might be a table that's specifically for new orders. The event looks at that table, and then when a new order appears, it will trigger an event of basically notifying my translator. So I'm gonna write in Python a translator that will be able to listen to these RDS events, and whenever it sees a new order, it's going to go ahead and I guess connect. I haven't built it yet, guys, so I'm kind of making it up. But it'll connect to the database, I guess, the queue table, and it'll read whatever the latest record is. So now we have the data. Maybe we store it in JSON format. I don't know. I got to figure that out. But whatever, that's irrelevant. The bottom line is now the translator has this new order record. Boom! So now what we need to do is we need to translate it into fix. So I would need to, I'm probably going to have a translator file, which is just a flat file. And that's going to be a mapping file, which is going to be aware of all of my fields. So for my front end, I will create a field for everything: order, quantity, side, symbol, whatever it is, right? So you can pull that straight out of the database. And now you need to be able to map that to fixed values. So for example, in the database, I could have quantity, a field called quantity, and that field could have a value of 100. So that's a 100 shares that someone's trying to buy, right? So field is quantity, value is 100, and then the mapping file will say quantity equals 38. And I guess the value of quantity is 100. So basically that will produce the string 38 equals 100. Wow, that sounds very complicated just to do something as simple as that. But that is all it is. That's all it is. So that's what we want to happen. And then I guess the final piece is I'm probably going to use Quick Fix for my fix engine. It is free. It should be free. So I will download and set up the Quick Fix engine. I will configure it to listen to my translator. So I'll have them talking to each other, right? So once a translator responds to this RDS event, it says new order, it consumes that, it translates it. I guess there should be some validation as well, perhaps, make sure that it's actually formatted properly or something. But regardless, it's going to receive that, and then it's going to translate it into a fixed format. Now you have a fixed formatted message. Now you can transmit that, I guess, via TCP/IP or whatever, how we're going to connect it to the fix engine. So you send that right over to the fix engine. The fix engine is going to do, I mean, this is an official fix engine, not something I built. So it knows what to do. It's going to look at my fixed message. It's going to validate it, make sure it's formatted properly, and give me errors or whatever. So that's going to be the first potential issue in terms of with my design, because originally I'm thinking about just giving it a very simple order message, but that's not going to fly at the fix engine. It's going to need to comply with the standard. So I'm going to need to have a properly formatted fix message. For testing purposes, I might just, I got to figure that out. I might just cheat just for now, because the main thing is I want to make sure this all works, right? I want to be able to generate a new order. I want to, here comes the cops, accident in front of me. I want to get in their way. Somebody's having a bad day today. Anyway, generate. It's not a bad accident. It's like a little fender bender, but I'm sure they're not having a good day today. Generate the order. Trigger this event in the cloud. Wake up my translator. Get the translator to make the fixed message, generate the fixed message, and then send it to the fix engine, and then the fix engine will do what it's supposed to do. I'm not gone that far yet, but anyway, this is what I'm working on. So obviously, as you know, whenever I learn something, that means tutorials are coming. So stay tuned. We're gonna have to do the AWS tutorial. We're gonna have to do the RDS tutorial, and obviously any bits and pieces of this project. You know, I'm gonna make different videos explaining different things that I did, especially the C++ stuff, because that's coming down the line, because we're not, you know, interpreted language is not good for low latency. I'm trying to get to the 1,000 transactions per second goal. So that's not going to happen with Python. So at some point, we're going to make a move to a hybrid model where the OMS server, so this is the order processing, is going to be done in C++. I'm going to keep the front end, just keep things simple. Front end is Python. tkinter, I might change that, I don't know, but for now it's tkinter. Python with tkinter for the GUI. And then it's going to be talking to a C++ backend that's going to do handling the orders and validation and risk checks. But that's down the line. I ain't touching that right now. But obviously that's going to be some tutorials as well. So stay tuned. This is the Computer Programming University. Now I'm going to pull over real quick and take a look at your wonderful comments, all of the insults about my hairstyle, my driving abilities, my outfit or lack of. One second. Let's see what kind of angry comments we have in the comment section. So, okay. Little E said, "Yo, what up?" Let me actually park properly, because I don't want no problem. I don't want no problems today. Somebody else got issues. They had an accident. I don't want any issues. I'm just going to the supermarket trying to get some sandwich supplies. That's it. All right, guys. Sir, how are you? I'm good, Shiv. Good to see you, Gaming Pro. No, how do you say that? Gamoni FTO, bald ahead. That's right. Clean cut. What? We don't want any hair to get in the way. You're a full stack developer. Right. Samantha K, what are you talking about? This is the trading application. So I built, as a long-term project, I want to build as close to as possible a full-on trading platform, the full deal. I know from a retail standpoint, you guys mainly see the client side, right? So if you're using Robinhood, you're using a mobile client, or you're using an app on your phone. If you're using what is it, interactive brokers or something like that, You could log in with the desktop app locally on your desktop, or you go to the website. That's what you normally see. But the world that I live in, I'm all in the back end. I'm in the front end as well, but I'm all in the back end, right? So I want to share that with you guys. The one of the tricky things is in trading, everything is proprietary. Every company is doing some proprietary stuff. So how do you teach people about things that are not public information? Like, I can't show you a production system. Now, if you're talking about, getting outside of finance, I mean, obviously, a database is a database is a database, right? I can show you a database because, a database at Starbucks, a database at whatever, name whatever random business. It's a database. It's the standard thing. But the trading technology, the OMS server, the EMS server, this smart order router, like, these are not things. Like, I could never show you an actual smart order router or any of these components. It's not something I can really show you guys, right? But what I can do is I can build a replica of it, obviously just using standard fundamental principles. I'm not going to be doing anything that's like secret or whatever, but I'll get to show you more than you would get to see anywhere else, because again, this stuff is all normally all top secret and you can't see it, right? So I'm using my 25 years of experience, understanding the fundamentals of how these things work, to build as much as possible. The entire system, middleware, how different applications communicate with each other, how you deal with things like what happens if you have a crash in the middle of trading. So you're in the middle, so you have an order that's in flight. Someone just generated an order. It was outbound to the database or whatever it was, right? And then the whole system just crashes. How do you recover, right? How do you gracefully handle that? You have queuing set up in the middleware to where it's actually able to do a recovery process, because you don't just sort of shoot out the data, from one component to the next. You have this messaging service, right, which talks to all the different components of the trading platform. So you have the front end, you have the OMS, which is order management server, which is handling the order, doing the risk checks, things like that. You have an execution management server, which is handling executions. You have the position server, which is tracking your positions. You have logging, obviously lots of logging. You have monitoring tools, which are monitoring. So I'm trying to build it all, and I'm trying to get as close as possible to the real thing, complete with schedule. At the beginning of the trading day, there are different applications that start. There's jobs that happen overnight. There's archiving that happens. You have to load up new records in terms of, there's certain events that happen. Like, let's say there was a merger with a company. You call it corporate action. So you have a corporate action process that runs. There's a lot of things that are involved in a modern electronic trading platform. So I'm going to try to build as close as possible to that. The goal is not for it to actually be functional in terms of like, this is something I could sell one day or something like that. It's really educational. I'm learning a lot by doing it. The more that I know about these systems, the better I am at my job. Yes, I'm definitely getting a benefit from it in terms of the skills and experience, because now I understand I have to make the decisions myself in terms of how to design this thing, right? So I understand the sort of questions that the developer had to figure out, like who writes these things, the problems they had to solve. So when these things aren't working the way they're supposed to, I have a better understanding of what's under the hood. I can communicate better with the developers. So if I have an issue that I need to escalate to the development team, the more that I understand about how things work, the better it is. So anyway, the bottom line is, I started with a stick figure version. It's called Mercari Maestro. Mercari Maestro is the name of the trading platform. It's super simplistic. It's really, really sort of crude representation of a trading platform. And then over time, I'm going to make it more and more complex. So what's happening now is we're now seeing the first phase of adding complexity, going beyond stick figure and moving slightly towards getting it to be sort of more mature. So right now the project is, first of all, cloud integration. So I'm gonna be moving the database to the cloud, and then also a fixed translator, and also setting up a fixed engine. So that's what we want to do. We want cloud integration, and I want um, a real-time sort of event-driven application, the translator, that's going to listen for new order events, sees a new order come in, translate the fixed, send it over to the fixed engine. So that's what we're doing. Let's see, what is this? Hell for review. Somebody said, "Shut up, idiot." Yeah, The Walking Dead. Thank you, man. Oh, somebody already handled it. Okay, I guess. I have a Redis. You have a Redis. You have a Redis cluster with only 3 nodes. You need more investments for that. Why do you say that, man? Anyway, that's all I have to say. So stay tuned for that. I'm gonna get my sandwich stuff, and then get right back into it. So I'm gonna start researching this whole Lambda, AWS Lambda, and this trigger event mumbo jumbo. Try to see if I can get something going today. I would like to at least design the database schema, actually set up the database, have an actual database set up with all my fields and everything available. I think it would make sense to have the database be ahead of the trading client, in terms of have all the possible fields that I want to potentially use be there, so they're there when I need them. So I'm gonna sort of I'm gonna add more and more features to the trading client over time. So right now I might just be using 3 or 4 fields, right? So I don't need all the extra, but as I add more, I want to make sure the database is ready for them. So I'm going to add as much fields as possible, try, that's a simple thing, just building a database, right? So I'm going to make it as close to the real thing as possible, and keeping in mind that the trading client is going to be really simple, and it's going to grow over time. Anyway, that I've said enough. All right, guys, until next time. Horizontal scalable server you need right now. Horizontally scalable server. I think you're going to have to add some more details to that in the replay. All right, guys, until next time. This is the Computer Programming University, and I'm out. I'm out.